Dear students, let us discuss the limitations of Dalton's atomic theory. We know Dalton put forward his famous atomic theory in the year 1808. According to his theory, matter consists of small tiny particles, individual particles known as atom. They cannot be further subdivided. Atoms of the same element are similar in all respects. Atoms of different element are different in all respects. Atoms of different elements combine in a simple whole number ratio to form compound atoms. Atom can neither be created nor destroyed. These are some of the important postulates of Dalton's atomic theory. But with the modern discoveries, Dalton's atomic theory was getting a number of limitations. First one is it does not account for the existence of subatomic particles such as protons, electrons and neutrons. Because from modern discoveries we came to know there are subatomic particles, that means atom can be further subdivided to give protons, electrons and neutrons. But in Dalton's atomic theory, we have assumed that atom can neither be created, atoms cannot be further subdivided. Therefore, Dalton's atomic theory does not account for existence of subatomic particles. The second one is it does not account for isotopes. In Dalton's atomic theory, we are saying atoms of the same element are similar in all respects. That means in terms of mass, size, in properties, in all terms they are similar. But if you see, for example, isotopes of your hydrogen, that is protium, deuterium and tritium. Well, in this case, if we see their masses are different. You see their mass numbers are different. This is protium, deuterium and tritium. Their mass numbers are different. But according to Dalton's atomic theory, they are saying if they are atoms of the same element, they must be similar in all respects. But here, these are the protium, deuterium and tritium are the atoms of the same element, that is hydrogen. But their mass numbers are different. Therefore, it does not account for isotopes. Similarly, it does not account for isobars. Dalton's atomic theory does not account for isobars. How? Let us see. We have argon and argon and calcium. Argon is having atomic number 18, whereas calcium is atomic number 20. So these are the atoms of the two different elements, but they have the same mass number. But according to Dalton's atomic theory, if the two atoms are atoms of the same element, they must be different in all respects. But here we are seeing they are similar in one respect, that is mass number. Therefore, Dalton's atomic theory does not account for isobars. Similarly, elements need not combine in simple whole number ratios to form compounds. According to Dalton's atomic theory, elements combine always in a simple whole number ratio. For example, hydrogen and oxygen combine in 2:1 ratio. Hydrogen and oxygen always combine in 2:1 ratio. Hydrogen and oxygen to form water. Similarly, carbon and oxygen always combine in 1:2 ratio. Sulfuric acid, hydrogen, sulfur, oxygen combine in 2:1:4. But if you see sugar or glucose or sucrose, C11, its formula is C11H22 and O11. That means the ratio is what? 11:22. 12:22:11. 12:22:11. This is not a simple whole number ratio. But according to Dalton, he says always elements combine in a simple whole number ratio to form compound atoms. But it is not a simple whole number ratio. So, it is not always true that elements always combine in a simple whole number ratio. Then the last one is the theory does not account for allotropes. We know allotropes are the atoms, different forms of the same element having different physical properties but same chemical properties. You see, diamond and graphite are two different forms of carbon only. So both of them burn to give carbon dioxide only. That means they are made up of carbon atoms, but their properties are widely different. Diamond, it has a very high refractive index, whereas graphite is totally black. Then the graphite is a very good conductor of electricity, diamond is not. Diamond is very hard, whereas graphite is slippery and comparatively very soft. Therefore, it clearly shows that the Dalton's atomic theory does not account for allotropes, because Dalton's atomic theory is saying atoms of the same element are similar in all respects. But here you see diamond and graphite, these are the two different forms of the same element. Therefore, the differences in the properties of diamond and graphite, both of which contain only carbon, cannot be explained by Dalton's atomic theory. So, these are the limitations or important limitations of Dalton's atomic theory. Hope you understood. Thank you.